Okay, so our last topic today is confidence intervals. So a level C confidence interval for the mean of a population has two parts. It has an estimate and a margin of error. So it looks like an estimate plus or minus a margin of error. And it also comes with a confidence level C, which gives us the probability that this interval that I give will capture the true mean in repeated samples. And the confidence level is kind of the success rate for the method. So it says that 80, say my confidence level is 85%. That means that 85% of samples that I take that give me this interval, which we'll talk about how to get to the interval, 85% of them will capture the true mean of the population. All right, so let me fill this out a little bit and then we can talk about it. There we go. Okay, so to calculate a confidence interval for the population mean, our estimate is going to be the sample mean, x bar, and our margin of error is this z star times the standard deviation divided by the square root of n. N is the sample size. Standard deviation is just given to you. And this z star is a special value that comes from our normal distribution. So z star is the z-score that has an area of C between negative z star and positive z star. Okay. For confidence levels that are commonly used, so 90%, 95%, and 99% confidence, the critical values are given to you in this table on the right hand side of the screen. All right. So for example, if I have Z of 1.645, my goodness, from negative 1.645, not sure why this isn't writing. There we go. Negative 1.645 to positive 1.645, the area between those two would be 90% in this example. All right. So how do we find these critical values? Well, again, Z star is the z-score for which the area between negative z star and z star is C. We have a table that gives us areas between the mean and z-scores. So all I want to do is find the z-score in my table that gives me the area that's half of C. Right? I'm going to cut C in half. And so now this looks like C over 2. And this is C over 2. Where now my confidence level C has been written as a decimal. Okay, so all you're going to do is look in your table for the area closest to C over 2 and find the z-score that it corresponds to. So let's try an example. So suppose I want an 82% confidence interval. So I'm going to look at my table now for the area closest to 0.82 divided by 2. So 0.41 go ahead and pull out your table. So remember, I'm looking at the values in the middle for area, and we're looking for the number closest to 0.41. Here's 0.4099, and here's 0.4115. So 0.41 is between those two. Which one is closest to 0.41? It's 0.4099. Okay, so that's the area, and I'm looking for the z-score. So I'm going to look up and to the left. And so my z-score, let's see, is 1.34. Does that make sense? Whoops. Okay, so what was the other one that we wanted? We wanted a 67% confidence interval. So again, think about your picture. So here's my normal distribution, 0, z star. And so now the area that I'm looking for is 0.67 divided by 2, which is what? 0.335. So go back to the table and look for the area closest to 0.335. And it's 0.334. Okay. So our z star is 0.97. Scroll up and to the left, you can see it's 0.97 for a 67% confidence interval. All right, so let's do one example of finding a confidence interval, and we'll do some more in class on Tuesday. The distribution of chemistry exam scores is known to be approximately normal with standard deviation 4.8. 10 students had the following scores. Use this to find a 95% confidence interval for the mean score of all students taking the exam. So here are the scores. Okay, so the formula for my confidence interval looks like, let me use black. Sample mean, that was my estimate, plus or minus critical value z star times the standard deviation divided by the square root of n. All right? And when I write plus or minus, what I mean is I'm going to do, I'm going to do the subtraction, and then I'm going to do the addition to get my interval. So I'm actually going to get two values, two endpoints. An interval has two endpoints. Plus. Okay. So I need to do both those values. So to do this, I need to know the sample mean. I need to know my critical value z star. I need to know my standard deviation sigma, and I need to know the sample size n. And all of those are given to you in the problem, or at least given the information to find them. All right, so we're going to start by finding some of these things. Our sample size is 10, right? There are 10 students, so n is 10. And we're given in the problem that the standard deviation is 4.8 right here. All right, I know that I need a 95% confidence interval, and so remember when we first introduced those, there was a table that gave us the critical value for 95%, so we're just going to look in the table. if you have your z-score table in front of you, you can see that the table for the 95% confidence interval is also at the top of that z-score table. All right, so let's find the sample mean first. So what do I do to find a sample mean? I need to add up the values and divide by the number of observations, in this case 10. So if I do that, I get 79.3. That's my x bar. All right, again, I'm going to look in the table for the critical value, and it was 1.96. And now I just need to plug everything into my formula. So I have 79.3 plus or minus 1.96 times 4.8 divided by the square root of 10. Now to get the interval, I need to do the addition and the subtraction. And when I do that, I get 76.325 to 82.275. What we say is that we are 95% confident that the true mean score for the exam is in this interval, 76.325 to 82.275. All right, so I'm going to let you try to do this one. Please read through the notes. These are the notes from the chapter, but read through these carefully. Do the extra problems that I've assigned for you for Tuesday, and be prepared with questions about this material.